Can start it. Thanks for staying here. It's good to start before more people leave. Well, this is a kind of different subject. The previous presentation was nice because it introduced a lot of the things that I'm going to tell you about. The idea is that to talk a little bit about how the concepts of open networking are leaving data centers and are going to the more complex networks in metropolitan areas and Metro Ethernet, edge, access, and so on. What are the consequences? What are the complexities on that? Then we are going to talk a little bit about the state of art in terms of open source initiatives for GPON products. And then I'm going to talk a little bit about our OS as a commercial alternative for these initial deployments. So first, an important disclaimer. My company is part of the ONF community. We work on CIBA. We believe that this group is doing a great job. The future will be on open source, but it takes time. It will take time until they are ready for real deployment. So the idea here is that we need to support this evolution, but we don't have to wait until it's done, until it's ready for real deployment. There's a number of companies that are going to the field with some initiatives on VOLTHA, but it's still in small scale. It's still something that has to mature. And we know that software matures in the field, not in the lab. So when open network meets metropolitan areas, data center applications are far simple than what we see in metro transport networks. There's a number of different applications. It's a variety of customers, a variety of use cases. You have different points in the network. We have the access, we have the aggregation, distribution, transport core. Each of these layers in a complex telco network requires different sets of protocols, different requirements. So the complexity here is quite large. So some of the solutions that we have for data centers, they will take quite a while until they get used for this level of complexity. And the disaggregation is following the same path, right? We start in data center because we have a simpler environment. Now we are getting to other points. There are a number of initiatives in different forums. There's the OCP, there's the TIP, Open Run. There's a number of projects happening everywhere. There's a lot of collaboration among these different projects. There's a lot of overlap. So it's happening. It's happening all across the board. And even at ONF, I think there is one project for each of the access aspects of the network. So there's a lot going on. The metro, as I said, it's a little bit more complicated. There's a lot of variability. There's a lot of different customers, different size, different networks, different applications. So it's quite heterogeneous. It's a big and complicated puzzle. If you go specifically for the GPON access, it's a quite different beast. In the edges, it sounds like a regular network with the switch applications, but in the middle we have all the complexity of the fiber. We have specific protocols. We have specific controls. So it's a different beast. It has a number of extra additions when we compare with a regular switch operating system. For those that are not familiar, just a brief introduction on what is the open source initiative in this area. This is the CIBA project. It involves a number of SDN related things on the top. We have the ONOS, which is the control plane, the network mediator. And specifically in terms of GPON, we have all this area here. We have VOLTHA, which is the virtual OLT, and we have the OLT in the bottom. So all the the GPON-related things are concentrated in VOLTHA, and there are all these complexities and connections in terms of becoming an SDN network. So as you can see, a number of pieces that are evolving together. They are in different levels of maturity. There are a lot of new technologies being implemented here. They still consume a lot of processing power. It's big servers, not easy to build, right? It's quite complex, and it's still something evolving. The proof of concepts that we have are still in very small scale, because just to put 1,000 ONUs in this side and simulate a real customer environment takes a lot of energy, so it's not easy. Even the simulator that we are using here is still limited in terms of scalability. So there's a lot to grow, but we can have a taste of how many components we have and how difficult it is to put all of them together. The ones that have tried know what I'm talking about. So there's a lot to be done. The initial focus for CBA was XGS-PON, because that's the white box that was available. This last year was a new design was announced by Paul, design offered by Deutsche Telekom with a GPON box. Today, actually this morning, EdgeCore has made a new presentation showing more details about this box. But at the beginning, it was just XGS PON. So there's no deployment yet in the field with GPON. It's limited. All this infrastructure was built on top of this abstraction layer provided by Broadcom. So it's quite Broadcom-centric, and it's still limited. For us, we deal directly with the SDK. For the rest of the community, they have to work on top of the abstraction layer, and it's still a work in progress. The last release made a lot of progress on that. There's a lot of things exposed, but things like triple play applications are just coming on board. So there's still no exercise on that. So
what is missing now for your opinion?
Well, I can leave the question for Dennis, if you don't mind. And it's quite SDN-centric. SDN, we talk a lot about SDN, but real big applications, it's not something that is popular in the market. It's still something that is still in evolution. The previous presentation talked a lot about Stratum. Stratum is a new generation of SDN trying to fix some of the initial things that were there in terms of how you can really reproduce what you are programming in your control plane in the ASIC, but there's a lot to be done. And the architecture is complex, and it's still high cost. It requires big servers, big boxes there. Again, this is just the reality, right? There's no criticism that's the right path. It's just a matter of what still has to be done. We are just at the beginning. And in terms of the real field application, we need a lot of scalability. Our own product, I think it took us almost 2 years until we have the right level of scalability and to be confident to go to the market. And when we go to the access, when we touch end customers, the complexity of the different ONU vendors and the complexity of the customer environment creates also a lot of burden too. So it's not easy. It's quite different from being in a segregated controlling environment and going to the front of your end customer and domestic customer. From last year, I took this quote from Paul. I hope he doesn't mind. There was, in his presentation last year, there was this question on when that OLT would be available. And his answer was, okay. It was, well, it depends on the software. Basically, it depends on the software. We have a great box. We have a very nice piece of hardware, but we don't have a solid software that can run there and can allow me to go to the field. So that's what we had, and that's still the reality. The video is there. So what we are proposing is, let's move on. Yes, there's a possibility today to stop buying black boxes and start buying white boxes. And create a path for this new future of an open disaggregated solution. We need to start disaggregating a lot of pieces. We can take a closed commercial solution and start opening interfaces, creating the hooks to connect to the new open components. And I'm going to show you how we are dealing with this. But the basics of any open OLT is to have this open OLT agent on the top. So that's the abstraction layer that is required for any box to be controlled by CIBA. And that's the initial path. So what's our approach? Is to start breaking some of the pieces apart, keeping some of the interfaces quite standard, like netconf on the top, keeping the open OLT agent in the bottom, creating gRPC interconnections. So start connecting the pieces, keeping some of the things that we believe we can do better, more self-contained, but evolving to establish these connections. This is our original architecture. It's if you take any of the commercial solutions, they will look more or less the same. We have an abstraction layer on the top of the SDKs, and it was built on our own purpose to connect to our control plane. But the evolution for that can be this. So if you can see it, I replaced the proprietary abstraction layer from the middle and started using ONF alternatives to that. So in the OLT side, I added ball on top of the two SDKs, and I put the open OLT agent and Stratum on the top of that, and they could be my abstraction layer. And with that, I could connect directly with Honest control plane. I can connect to VOLTHA, and I can take all the benefit of being kind of ASIC or hardware independent, following this path. And even on the top of the device drivers, I took the physical abstraction layer that is one of the components in Stratum to abstract the device database. There are some tricky things here on optics that I'm not mentioning. Optics is one of the most sensitive things in our experience in the field. We have our own way of dealing with it, with the variety of transceivers that you have in the market, but that's another topic. Even on the bottom, we don't rely on Open Network Linux. We have our own distribution of Linux based on kernel. We can control the packages and be sure that we have inside the box just what we need, and don't carry all the Debian 9 together as we have with OpenONL. So what's the call to action? I think we can, as I said, we can start buying white boxes. They are reality. They can be deployed in the field if you have the necessary commercial solution solid that you can put there. And in the future, you can transition whenever you want. So the infrastructure will be there. The interface are going to be the same. The connections with the management systems can be the same, and just transition when you feel it's comfortable, when the scalability achieves what we need, or even keeping both in the field. So that's an alternative. We don't have to wait. So we can move on from considering the white boxes just as lab toys. And let's be clear, that's what these white boxes are today. So there's a lot of experiments, but there's none in the field. In parallel, we need to support the open source evolution. Right, VOLTHA is in the right track. I just got a message today that they are organizing the group in terms of being more objective, in terms of having a more product-oriented development environment. There's this balance on adding features or building some stabilization in the infrastructure, and we have to go in this direction. So that's the way to go. So we have both, and we need to support both initiatives. Just to finish where we are on this. We have already something that is pretty similar to what VOLTHA offers. We can already extend VLANs. We have a basic layer 2 working there. Maple is working. We can provision ONUs. So we are more or less at the same level and making daily progress on exposing more functionalities, mostly on the switch side of the OT, because the OT side is more or less the same what we have in our own box. So we don't have too much work there. The work that we have is really adding layer 3 and eventually MPOS on top of this box. And there are some other possibilities, like even integrating VOLTHA. In this box, if you know we have a Xeon processor, then we have a lot of processing power. We can do a lot inside this box. It's not just a pure thin OOT layer. Currently, we have support for x86 and PowerPC and Maple. And we are, as our original product is based on Strata XGS, we need to extend some of this functionality to DNX, and that's the biggest challenge. And in parallel, we are working also with Tibit, with the microplug. We have made it already work. We created a container inside our OS to control it with using some Python scripts. And it sounds that we can easily integrate. We have made some experiments with a third-party ONU, XGS PON. And I think it's a good complement. We can use some of the 10 gig or 25 gig ports, just plug this and extend to have a mix of GPON and XGS PON in the same box. So that's quickly an overview on what we have. I left a lot of time for questions. I can start answering yours.
What is missing? I mean, are you supporting multicasts for now?
Yeah, I support multicast. And I think that's the big evolution in Broadcom on the BAW 3.1.
But it's mostly in a switch chip to work with the
no, it requires support on on how you map things between the two, right? That's the thing. Because the BAW, in fact, it covers both the switch and the sock. So yeah, you need to make the bridge between the two of them.
Okay, and how about the rate limit per service?
We still didn't see this on BAW. We still did evaluate that. Our implementation is directly on the top of the SDK, so we fixed this there. So we still don't know what we are going to do, if we're going to through BAW or if we're going to deal with this directly on the SDK. Probably directly on the SDK is our best approach, because I don't need to use BAW. I'm using BAW today to make my own OLTs VOLTHA compatible. But my implementation goes directly in the SDK, and then I can fix and I can deal with all this rate limits and mapping gem ports and TCONs and all sorts of things.
Okay, so this equipment is going to work with controller VOLTHA? Or it's complete
no,
software?
It's a complete software.
So you load it onto the white box, and it's just like you take it from Nokia or Huawei?
Yeah, it's become a black box, right?
Okay.
But you can, it's ONI, you can take one and put another. So it's your choice. So when the time comes that
Okay,
VOLTHA,
so it's like a commercial software for white box?
yep,
Great. And it's working. I mean,
and it's working. Okay.
We have a question and a comment. I think in one of your previous slides, you kind of showed your software with some components of SIVA.
Mm-hmm. Mm-hmm.
So I'm trying to understand, maybe when you transition, right, you're still showing some of your components there. So you're taking parts of SIVA, putting it in your software?
Mm-hmm. Yeah, that's great. We don't know the final answer for that yet, right? What we are doing is to make some experiments. We are removing some piece of our software. This is really a lab experiment. We are removing, because there's an interesting aspect of using these open source components here, because it saves you time and it makes you hardware agnostic. So I could take another implementation with a completely different chipset on the bottom of that, not Broadcom, and it would work. So that's the beauty of that. Even with Stratum, I could have a Tofino underneath, and it would work. So it's more a vision than a real experiment. So we are doing some of these experiments. Actually, our approach, as I said, we are making our black box OLT into a VOLTHA compatible one. So the initial thing that we did was exactly to remove our OLT manager, that orange box, and put in VOLTHA there. How much we are going to extend and contaminate, in other words, the rest of the black box code, I don't know. There's a limit there that is useful and makes sense, but we still don't know the limit. We are still making some experiments there. Yes, yes. I still have my proprietary database here, doing my FCAPs, doing all this left side here by myself. And even if I made this transition, I will probably keep some of that. I still think my database is better. I still think my FCAPs is better. So I will try to keep some of these components and make this hybrid solution and find the right place to cut. Mm-hmm.
It doesn't have to be open source. So this one solution, always an option.
And you know, that's an interesting comment, because even in the open source, there is opportunities to be better. As I mentioned, the Open Network Linux is generic, is helping a lot the speed, the go-to-market strategy for a number of OS vendors. But as everything that is generic, there's always something that doesn't work very well in that specific box. And so we think that we can do better. We think that we can manage better some FCAPs, for example, optics, even some of the diagnostics in the box. We believe that we can do better. So there's a lot of ground between the pure open source, free code, and the black box solution. There's a lot of gray areas in the middle. Mm-hmm. Mm-hmm. Sure. Great.
Is it? I mean, you said it's commercial. I mean, I said it's commercial, but it's a commercial solution. And how about the provisioning? Because a lot of ONT, all the idea of that is to replace the black box from vendor X and put this box and to be able to use any ONT from any vendor you want, just to have a better negotiation position. The different vendors do provisioning in a different way. Huawei does a different way than ZTE, than Nokia, and so on. And if, for example, somebody wants to have XML file transfer over ME7 index 0x11, is it possible to do it by ourselves to add such a feature, or it will have to be added by you?
Well, we went to this path of having a kind of proprietary provisioning thing. And we are trying to get away from that, because it never ends, right? There's a common ground for a common provision, an open OMCI thing that we can use across the board. Every vendor tries to do something better, but at some point you create a lock. And we are trying to get away from this lock. We created our own lock. It's called RG Profile. That is great. But every time we have a new feature, we have a new customers, there is a new requirement. Well, we want to provision that specific thing, we need to configure that specific thing, we need to change the ONU, and so on and so forth. So I think the ideal place to be is to have this common ground that you can take wherever ONU in the field and stay in the common piece.
Yeah, it's not always possible, and the idea is, well, it's okay when you build a new network.
Mm-hmm.
But if you want to replace existing OLT, just to make your position better with negotiations with OLT vendors, with that box, you have to adjust the box. So this is the advantage of the box to the ONTs that you have.
Yeah, we do this every day. Answering your question. Yeah. Yeah, you're right. There's a common set that works okay, but they have every day, and that's what I said at the beginning. So you never know what you are going to find in the field in terms of a new ONU. So yeah, we have to do this. It's usually some tweaks in the OMCI. There's something hidden things, external addition. So that's what we do.
Some private extensions that are.
Yeah, we need to be compatible with this private. We try to not add our own private extensions, but we have to deal with others.
Yeah, with the
Yeah,
others.
yeah.
You have to just do reversing like of them.
Yeah, we do this all the time with fiber home, with Huawei. That's what happens every day.
Okay, so I have another question, but it will be after that.
Okay.
Ricardo, do you see the option to have the ONU manager process, open ONU agent, as a replaceable part inside your NOS?
I think so. We have an OMCI controller in the middle of this, which is quite pluggable. And having a standard OMCI protocol going through, it's not a big deal.
Could that be scriptable, that you have adapters, different versions of adapters?
Just like
That's not the plan today, but we have control on these pieces, right? If we need to extract the controller and put the OMCI controller outside, that would be, as I said, there's a lot of intermediate grounds. The way we are working today is towards just porting as is inside the box. Once we have it there, there's a number of possibilities. And I believe that if this path happens, there will be a transition and there will be new requirements in this direction. But it can be done. It's not the initial target.
okay, technically, so if you add a new ONT with some strange provisioning, you add features to your OMCI stack, or you just do like Nokia does. It's like you recognize ONT and pick up this stack. In that case,
No,
you pick up the other stack.
No, I would have to add to my OMCI.
So you have one stack all the time with some extensions. You don't do like one stable stack for Huawei, the other
No,
for ZTE.
no,
All right.
it's just one.
Okay.
I try to extend to accommodate everybody in the same. Hi, Jeff.
So it seems like there's three things you're describing here, right? There's the taking your stack as is and putting it on the boxes. There's the far right-hand side, which is, okay, now let's remove that and install the traditional CEVA VOLTHA stack. And then there's this place in the middle that can be anything,
Mm-hmm.
which we can talk about until days end.
Yeah,
So
that's
do
right.
you know, can you give some kind of indication on the first step, which is your NOS as is, when that will be available to run, you think, in a production network?
Mm-hmm.
Do you have a list of ONUs that are already qualified with your own CI stack? And
Mm-hmm.
kind of just touch on what that timeline
Sure.
looks like for a commercial NOS to run on a white box OS
Mm-hmm.
without the
Sure. That's a natural next question. Our goal is to be ready now in October for basic proof of concepts with pure VLAN, right? You use the aggregation out of the box and the transport and BNG out of the box. So that's the step one. Probably with just one of the maples running. We are still working on handling the 4 maples in parallel. So that would be the initial case. You can deploy like 16 GPON channels, and that would be the first exercise. And the idea is through the end of the year, we would become a kind of basic GPON box with a basic layer 3 inside, and with all the GPON channels running, and all all the GPON side would be what I have today, with all the list of compatibility that I have. I have this code in the field for 2 years, so we have gone through a number of different situations and ONUs and scalability. So the list is already quite big. Sometimes we find some weird things in the field, but most of the alternatives are still there.
just roughly how many different ONUs do you support in that basic NOS? One is 10?
Yeah, it's a range of 10 to 20. Yeah, because there's not so many other vendors. Sometimes you have just the branding. Of course, there's always surprise. So there was something that was working, and then let's say Fiber Home tweaked it a little bit, the OMCI, changed the code, and it doesn't work anymore. Then we have to do some reverse engineering to make it work again. So that's part.
Do we discuss all the time the XGS?
XGS. XGS, we are still far from this, because this implies the OMCI is quite extended from the GPON. What we are doing today, we are counting, for example, with Tibit, we are doing XGS because all the stack is built on top of the TAPI, so we don't need to take care of that. We just plug it, run the API, and it creates a VLAN, and it's done. So we don't need to deal. To have a full support in our OS is a little bit different because we need to extend our OLT manager.
Okay, so you mentioned, so you deal with GPON, general GPON. So you have this
GPON, yeah.
ASG64 from EdgeCore.
Yeah, I have.
Okay. This is something like, yeah, we just can see but not buy.
Yeah. Okay. Okay. Thank you.